Hi there, grade 8. So I'm going to discuss lesson 5 of unit 1, and it's about special case on the product of binomial and trinomial. So we're going to multiply a binomial and a trinomial. But before we do that, let's try to find out the relationship between the two factors. Okay, so here, we have, let me select the color. Okay, so for example, we have x plus y here, and then this is about to be multiplied with x squared minus xy plus y squared, which is a trinomial factor. Now, if we're going to consider x and y as the first and the second terms, respectively, of this binomial factor, so let's find out the relationship between the two factors. The first factor of this binomial factor is the square of the first term of this trinomial factor. Likewise, the second term of this binomial factor is the square of the last term of this trinomial factor. And the middle term is the product of the first term and the second term of this binomial factor times -1. So we have negative xy. S- So that is how the binomial factor is related with that of the trinomial factor. So let's consider these two factors. Again, we have a binomial factor here and a trinomial factor. The first term of the binomial factor is the square here of the first term of this trinomial factor. Also, the square of the second term of this binomial factor is equal to the third term of this trinomial factor. And the middle term here is the product of the first and the second term, which is x times -y times -1. So we get xy. So that is how the two are related to each other. So how do we find for a pattern? Similar with what we did in the previous discussions on other types of special products, we were able to derive a pattern by considering the distributive property of multiplication. And exactly that is what we're going to do also. And let us consider these two factors. So we're going to multiply x to all the terms of this trinomial factor. So we have x times x squared here. We have x cubed, and then x times -xy. We have negative x squared y. And then x times y squared. We have xy squared. Now we will multiply the second term of this binomial factor to all the terms again of this trinomial factor. So we have y times x squared, we have x squared y, and then y times -xy, we have negative xy squared, and lastly, y times y squared, we have y cubed. And then combining like terms will bring down x cubed. Take note that the middle terms are cancelled. So we have only x cubed plus y cubed. So when we say x cubed, since we represent x here as the first term of the binomial factor, and if we say y cubed, since y is represented by the second term of the binomial factor, so we have actually the product on the special case of binomial and trinomial is equal to the cube of the first term plus the cube of the second term of the binomial factor. Okay, so if I'm going to rewrite the formula, we have quantity x plus y times quantity x squared minus xy plus y squared is only equal to the cube of the first term of the binomial plus the cube of the second term of the binomial. Likewise, class, if this is x minus y, so this will be x squared plus xy plus y squared. The product here is the cube of the first term of the binomial factor minus the cube of the second term of the binomial factor. Now, if the relationship between the two factors here exists in these examples, we're going to apply or we're going to make use of this pattern. So let's start working on the example exercises. So let's check. Now x plus 1, the square of the first term of this binomial factor, this one, is the square of the first term, or the square of the first term of this binomial factor is the first term of this trinomial factor, while the square of the second term of this binomial factor is the third term of this trinomial factor. And the middle term is the product of the first term here and the second term times negative 1. So we can make use of the pattern. So the first pattern. So what we will just do is get the cube of the first term here plus the cube of the second term here. So we have x cubed plus 1. That's it. Let's work on number 2. The square of the first term of this binomial factor is the first term of this trinomial factor, while the square of the second term of this binomial factor is the third term of this trinomial factor. And the middle term here is the product of the first term here and the second term times negative 1. So we can make use of the pattern. So we will just get the cube of 5x. So the cube of 5x is 5x times 5x times 5x. So we have 125x cubed minus cube of 3. So we have 27. Here, square of 7a is 49a squared. Here, while square of 1 here is 1, which is the third term of this trinomial factor. And the middle term here is the product of the first term and the second term here times negative 1. So we have negative 7a as the middle term of this trinomial factor. So we can apply the formula. So the answer here will just be the cube of 7a, which is 343 a cube plus the cube of 1, which is 1. There. Now, the square of the first term here is the first term of this trinomial factor. The square of 1 here is the third term of this trinomial factor. And the middle term here is the product of the first term and the second term times negative 1 of this binomial factor. So we have negative 3x. So we can apply again the formula. So this is like getting the cube of the first term. So we have 3x times 3x times 3x. So we have 27x cubed. And the cube of the second term of the binomial factor, 1 cube. So we have 1. For number 5, The square of 6b is the first term of the trinomial factor, while the square of negative 1 is the third term of this trinomial factor, and the middle term here is a product of 6b and negative 1 times negative 1. So we have 6b here. So the product for number 5 is the cube of 6b, which is 216b cubed, and then minus cube of 1. So for number 6, we have square of 9h is 81h squared. Square of 3 is 9. While the product of 9h and 3 times negative 1 is negative 27h. So we can apply also the formula. So we will just get the cube of 9h, that is 9h times 9h times 9h. So we get 729h cubed, 729h cubed plus the cube of 3, 27. There. So let's continue until number 10. So for number 7, so square of 11a is 121a squared. Square of 3 is 9. And then the product of 11a and 3 times negative 1 is negative 33a. So we can make use of the formula. So we will just get the cube of 11a, which is 1331a cube, plus the cube of 3, which is 27. So here, square of d is d squared, square of 1 is 1, and the product of d and 1 is negative d. Okay? So the product for number 8 is the cube of the first term. We have d cubed plus the cube of 1, which is 1. Now, this is supposedly d squared. I'm sorry. Okay? So, we have the square of 3ab equal to 9a squared b squared. And then square of 2cd equal to 4c squared d squared. And then the middle term here is the product of 3ab and 2cd times negative 1. So again, we can make use of the formula. So this is just getting the cube of the first term. So that's 27 a cube b cube plus the cube of 2cd. So we have 8 c cube d cube. Last, so y here is the square of the first term of this trinomial factor, while 1 is the square of, or 1 is actually, or square of 1 is actually the third term of this trinomial. And then the product of y and 1 times negative 1 is negative y. So we have the product equal to the cube of the first term, y cube, plus the cube of 1, y cube plus 1. So that's it. So whenever you multiply special case on the product of binomial and trinomial, so you have to see if the relationship satisfies with this pattern such that the first term of this binomial factor is actually the square. So the square of this will be seen in the first term of this trinomial factor, while the square of y will be seen as the third term of this trinomial factor. And the middle term here should be the product of the first and the second term times negative 1. So if those conditions exist, then we can make use of the formula. So I hope you are able to understand our discussion. So see you